All right. Good morning. Here we go. Let's talk about some properties of equality. So we're starting to get into some proofs. So we have lots of properties, and I'm going to tell you that these properties are kind of interesting. You have to really look at them carefully to understand what they're talking about, especially the way that they're written. So these are the properties of equality that we're going to be looking at today. And all of these properties, this is the one test that I cannot do in Delta Math. So this is a test that I'll be grading by hand. And you have to know all the properties that we're going to be talking about. And it's pretty much matching. There will be a couple of proofs, but mostly it's matching and a few other things like what you just did in the bell work. So statements like that. Conditional, inverse, converse, contrapositive, those kinds of things as well. But mostly it's matching, and do you know the properties that we're going to be talking about over the next few days? So here we have the properties of equality. These are algebraic properties that we have been using now for quite a few years, okay? So it's just reiterating stuff that you already know, but you might not have seen it. So the addition property of equality says if I start with an equation, something like A equals B, if I have two things equal to each other, a left side equal to a right side, then the addition property of equality says that if I add a number, add something to the left-hand side, then I can add the same value to the right-hand side. So I can add something to both sides of the equation. Add it to the left and add it to the right. And so you can see here what changed. C, you can see, funny. Not funny. Okay. We added the same number to the both sides. And this is exactly what we do when we're solving equations. We add 2x to both sides of the equals, or we subtract 5 from both sides of the equals. So when we're solving equations, this is how we solve them. We use like the addition property of equality, or the subtraction property of equality, which again says if I start with an equation, one side equal to the other, then I can subtract something from both sides. So I can take the A and I can subtract a value from the left, and I can subtract a value from the right. Okay, so I can add things to both sides, I can subtract things to both sides. What's the multiplication property of equality? If I have an equation,
A times B equals B.
Yeah, if I can multiply both sides of my equation by a value. I can multiply both sides of the equation by a 2 or a 5 or an X or a Y, okay? As long as I do it to both sides, that is allowed. The division property is the same thing. If I have an equation, A equal to B, then I can divide both sides by the same thing. So A divided by C would be the same as B divided by C. Again, I can divide both sides of the equation by a number, and it's going to keep my equation balanced as long as I do that to both sides. So if I have A times a quantity B plus C, what is the distributive property? What are we doing? Yeah, what operation is distribution? Multiplication. So we are multiplying A times B plus A times C. So we are distributing that A to both items inside the parentheses, and that's the distributive property. You're very good at that. The substitution property, if I have two things that are equal, if A equals B, then A may be replaced by B in any expression or equation. So I can trade out the A and pop in the B. So the A comes out, the B goes in, it's taking the place, okay? So that's just substitution. The reflexive property, A is equal to A. It's like its own reflection. A value will always equal itself. That's true all the time. 2 is equal to 2. X is equal to X. 12 is equal to 12. It's a reflexive property. Yes, sir?
So in a vertical, like the vertical thing, like the...
Vertical angles?
Yeah.
Mm-hmm.
It would be a reflective property, like the cross.
So, yeah, you would have, like here, X is equal to X. Those two angles are the same value on the left to right. These two angles are both Y. Mm-hmm. The symmetric property basically is how we say if A equals B, then B equals A. You can flip that equation around so that it's exactly how you want to see it. It's the same as saying, like, X equals 5 or 5 equals X. These two things have just traded places. Things can spin around an equal sign so that they are reflexive or symmetric is the word. There's either way works. The transitive property is a new one. If A is equal to B and B is equal to C. If A is equal to B and B is equal to C, what do you think is true? Very good. A is equal to C. A and B are the same thing, and B and C are the same thing. Doesn't that mean that A and C must be the same? Yeah. So that is the transitive property. It's kind of like substitution. In fact, either one is appropriate most of the time. Okay, so here we want to practice with these properties. Here, if K equals 3, then 3 equals K. What property allows us to swivel around an equal sign? Symmetric. That's the symmetric property. Good. If 2x equals 14, x equals 7. How did they know that? What did they do to get x equals 7? Division, yeah. To get x by itself, what did we have to do to this equation to start? Divided both sides by 2. What property allows us to divide both sides? Division. The division property of equality. All right, what property says 10y is equal to itself?
Reflective.
Yeah, it's your reflection. That's the reflexive property. You're just looking at your own reflection. That is the reflexive property. All right, I love these. Number 4, we have this equation, negative 5x minus 1 equals negative 11. Imagine if you were to try to solve that. What would you do? You would add 1. Let's see, you would add 1 to both sides. And is that what they did to get negative 5x equals negative 10? Yeah, so what property did we use to do that? Yeah, we added 1 to both sides. So that would be the addition property of equality. And again, this is the thing that's helpful. What operation are we doing to get to the next step? And that's the operation that we are justifying, okay? Okay, if 10a equals 2b and 2b equals c, then 10a equals c is what they're saying right here. What property is that? Transitive, very good. Transitive is pretty easy to see because we have a couple of equations, and you can see there's some like repetition going on there. It's got the two b's a couple of times, and then we draw the conclusion from the beginning to the end. So that's the transitive property. Number 6, what's that? Distributive, very good. That's an easy one. That is the distributive property. All right, number 7 is interesting. When you look at the start, we just have this simple equation, 6y is equal to 24. But then we have this other thing. What did they do to this secondary? They subtracted 3. What allows us to subtract 3 from both sides? The subtraction property of equality. Yeah, we're allowed to subtract 3 from both sides. So that is the subtraction property of equality. All right, number 8, if 10x plus w equals 41 and w equals 1, what did they do there with the 1? They substituted it. Very good. So you can see what we started with was this interesting 10x plus w equals 41 equation. And then what we ended with, it's good to notice what changed. So the original w changed and became a 1. So they took out the w and replaced it with the 1. And what property allows us to replace something? The substitution property. All right, number 9. If 3x equals 2y and 2y equals z, then how come 3x equals z? Transitive, very good. Again, you can see the repetition there and a couple of equations, so that is transitive. The transitive property. And again, hopefully you'll get used to these. What's happening on number 10? Addition property. We're adding 4 to both sides. The addition property. Good. Addition property of equality. 11. What's happening on number 11? Symmetric. Symmetric. All it's doing is spinning around the equal sign. That's the symmetric property. Very good. Symmetric property. 12 looks scary. So notice what we started with. They also gave us a value that x is 5, and then what changed in the then portion? They replaced the x with a value. So they took out the x and they plugged in the 5, and that is the substitution. Very good. They took out something and plugged in something, so that's the substitution. Number 13. Starting with a very simple, m equals -2, what did they do to get 8m? Yeah, they multiplied both sides by 8, so that is the multiplication property of equality. God, I don't know why multiplication is so hard to spell. Multiplication takes all of my focus. Okay. What about 14? Distributive property. It's only written in reverse, though, yeah? We could use the symmetric property to spin it around, but that is the distributive property. Very good. All right, distributive property. Any questions on properties? No. Okay. All right, now let's practice doing a few proofs here. All right, so what is a two-column proof? We started introducing proofs. We didn't used to do it this way, so we started introducing proofs using algebra. Back in the mid-2010, 2012, 2014, somewhere around there, we didn't used to do it. Proofs were a giant, I think, struggle. And then we started doing this, and it sort of helps a little bit since we've all had algebra already. So a two-column proof is a common format used to organize a proof, and the statements or steps are listed on the left-hand side. So you see here we have statements on the left-hand side, and the reasons justifying each statement are listed on the right-hand side. So it's the statements and reasons set up here. And we want to use what can be used as reasons. Any of the properties we just talked about, properties, the properties of equality, any definitions that we know, and postulates or theorems, like the segment addition postulate or the angle addition postulate, and we'll talk about all these things again, and any theorems. When we started this unit, we were talking about inductive reasoning. Inductive reasoning is when we recognize patterns in something, and then we make a conjecture based on an observable pattern. And so that's inductive reasoning. When we make a logical proof, we are using deductive reasoning. We are using theorems and definitions and properties to explain a logical process of things. So this is deductive reasoning, where we are using our knowledge of theorems and definitions to make a logical argument. So when we write a proof, we are going to use the properties of equality to complete each of these algebraic proofs. We have always the given statement. This is the stuff we get to start with, and the given always goes in step number 1. And the reason for it is that it was given. So this is given information, stuff that they are telling us is true. Okay, so we're starting with the equation 4x minus 1 equals 27. And our job is to prove that x equals 7. And you can see that that should be the last step in our proof. So the given is always the first step, and the proof statement should be the last step. And they should be identical. And in between, you can see we've filled in the steps here. We just need to figure out the reasons today. So how do we go from step 1 to step 2? What are we doing?
Addition.
Yeah, we are adding 1 to both sides here. And the reason we're allowed to do that is the addition property of equality, which says we are allowed to add 1 to both sides. And so you can see, if we were to show the work for these steps, it's that mid-step in between that is our reason that we're allowed to do that. So a kind of interesting way to do that. To go from step 2, 4x equals 28, how do we get to step 3? What do we have to do?
Divide.
Yeah, we would be dividing by 4 on both sides. And of course, then, because we're dividing on both sides, that is the division property of equality. All right, so you can sort of see how I'm showing the steps, and the showing of the step really is the reason for the following line. Okay, questions on that one? Pretty easy, right? All right, so let's look at number 2. Again, the given statement is a number divided by -6 plus 2 equals 5, and the reason is that that was given to us. Always, always. And we're trying to prove that a equals -18. So step 1 to 2, what did they do? Yeah, they subtracted 2. That is the subtraction property of equality. Subtraction property of equality. Now, if I have a number divided by -6, multiply. Very good. How do we get a by itself? We multiply both sides by -6. And so that would be the multiplication property of equality. And feel free to abbreviate much like I am. You do have to be a little bit careful with substitution and subtraction, right? If you wrote sub for both, is that clear? No. So do be a little bit careful with that. I'm also okay if you just did like subtraction. Yeah, that would be fine too.
Yeah.
I'm totally okay with that. Okay, well, great. Awesome sauce. So let's go on to number 3. We have a fairly complicated equation to get going here. We want to prove that x equals 2, so the given is first. And how did they get to the negative 18x? Distributive property, absolutely. That is the distributive property. You can see how I'm changing the colors here, so you can see my green arc marks tell me what the reason is. All right, then how do we go from 2 to 3?
Subtraction.
Yeah, we're subtracting 27 from both sides. Subtraction property of equality. Very good. You know what's kind of nice about proofs? They give you the beginning and the end. Should you ever get them wrong? No. So you should be able to get there logically as you go. So it should work. What should we do to go from step 3 to 4? Division, dividing both sides by negative 18, and we see we'd get negative 2. Division property of equality. Fantastic. Do you guys have any questions for me? I think that's the end of what we're doing today. Yep, that's for the next day. So, fantastic. We will stop there. We have a little worksheet today.